This is part 2 of topic 6.12, integrating using linear partial fractions. And actually this lesson is just going to consist of one integral, and this is a definite integral. So I want to kind of go through when you're given an integral, what to think about. The first thing is that the derivative of the denominator is not in the numerator. So we definitely don't have a natural log of that denominator right off the bat. The second is we don't go straight to partial fractions because the degree of the numerator is 3 and the degree of the denominator is 2. So to use partial fractions, you have to have a smaller degree in the numerator. So then you think, yes, division. Now, with this one, we're going to use long division because our divisor is not of x minus a form. So I do want to go ahead and get set up because I don't want to forget that that's what I need to do after I divide. Okay? So let's go ahead and divide. So we're going to use long division. And we're going to have x squared minus x minus 6, have x cubed plus 0x squared minus 4x minus 10. Okay, remember we're going to focus on that x squared, and of course we will choose x. So that would be x cubed minus x squared minus 6x. Don't forget we're subtracting everything. That minus 10 looks funny there. And what we end up with, and of course we planned that, is 0 plus 1 would be x squared. Negative 4 plus 6 would be a plus 2x. And then, of course, we'll bring down that minus 10. Now, we can keep going because we can multiply x squared by 1. So x squared minus x minus 6. Subtract everything. We planned that one. So 2x plus x gives you a 3x. A negative 10 plus 6 gives you a negative 4. So this is our remainder. And so actually, we have plus 3x minus 4 over x squared minus x minus 6. Now, we'll go up here and we'll write that. The integral x plus 1 plus 3x minus 4 all over x squared minus x minus 6 dx. Now, what do you notice? We need partial fractions. So this right here we will have to write with partial fractions, okay? I'm going to give myself a little bit of room here and go ahead and take care of that. So we have 3x minus 4 over, and that's factoring, that would be x minus 3 times x plus 2. And we're going to say that that's equal to a over x minus 3 plus b over x plus 2. And of course now we have 3x minus 4 is equal to a times x plus 2 plus b times x minus 3. We're going to have x equal to negative 2 and x equal to 3. And when x is negative 2, this left-hand side, we get a negative 10 is equal to negative 5b. So b is 2. And I always highlight those. And then when x is 3, we have 5 equals 5a, so a is 1. So now we can rewrite this as the integral from 0 to 1 of x plus 1 plus 1 over x minus 3 plus 2 over x plus 2 dx. Okay, so that's equal to 1/2 x squared plus x plus ln absolute value of x minus 3 plus 2 ln absolute value of x plus 2, and we are going to evaluate all of that from 0 to 1. Okay, so I'm going to plug 0 in first, and you're going to see 0 and, excuse me, we're going to plug in 1 first, so let's do that. 1/2 plus 1 plus ln of 2 plus 2 ln of 3. And now I'm going to plug in 0, and of course these will be gone when I plug in 0. So I have ln of 3 plus 2 ln of 2. Okay, so now we can go ahead and combine some of these. We have an ln of 2 here, and we have negative 2 of them there when you distribute that. So that's going to be a negative ln of 2. Why don't I just go ahead and take care of this? 1/2 plus 1 is 3/2, and we have a negative ln of 2 there. And then here I have 2 ln of 3 minus 1 ln of 3. So now I just have 1 ln of 3. And that is our final answer. So, some strategies of where to begin and what to do when you have these integrals, and that concludes topic 6.1.